Suppose you have a wildly complicated model, a deep network, or a giant ensemble, and it just made one prediction you'd really like to understand. Explaining the whole thing globally is hopeless. Its decisions surface twists and folds in ways no simple story can capture. So Lime makes a wonderfully practical bet instead. It gives up on explaining everything and zooms in on just one prediction, where even a monster of a model looks almost simple. Today, we're unpacking how that works from a paper by Ribeiro and colleagues in 2016. To see the trick clearly, follow Lime as it explains a single prediction, one step at a time. The whole procedure is surprisingly hands-off. Start with the one input you care about and nudge it many times over. Toggle words on and off in a sentence, or switch patches of an image on and off. Each nudge gives you a slightly different neighbor of the original input. Then feed every one of those perturbed versions to the black box and record what it predicts for each. Notice that Lime never peeks inside the model. It only asks questions and listens to the answers, which is why it works on absolutely anything. Now, weight those samples by how close each one stays to the original input. Neighbors that barely changed count heavily, while perturbations count for little. That weighting is what keeps the explanation local, anchored right around your instance. Finally, fit a simple, sparse linear model to that weighted little dataset. Its coefficients tell you which features push the prediction up and which pushed it down for this one case. A readable, honest local snapshot of a complicated decision. So why go local at all, instead of explaining the whole model? Line the two ambitions up side by side, and the answer is obvious. Trying to explain a complex model globally means squeezing all of its twists into one simple story. And that story is almost always wrong. A single linear summary of a deeply nonlinear model smooths over exactly the behavior you were trying to understand, so it looks tidy while quietly misleading you. Lime accepts a smaller, truer goal. It only claims to be faithful in a local neighborhood of one input. And locally, even a fearsomely complex boundary is roughly simple. So the little linear model it fits genuinely matches how the black box behaves right there, which is exactly the region your prediction actually came from. Strip it down, and three ideas carry the whole method. Perturb and sample around one input. Lime probes the model by generating many small variations of a single instance and collecting how the prediction responds to each of them, building a little dataset that describes the model's behavior in that one corner. Fit a weighted local model. Those samples, weighted by closeness, train a simple linear model or small tree whose coefficients reveal which features drove this particular prediction up or down in plain, readable terms. Works on anything at all. Because Lime treats the model as a query-only black box, staying model agnostic, it explains any classifier you throw at it, text, images, or tabular, which is why it popularized local explanations right alongside SHAP. All right, let's lock in the essentials. Lime explains a single prediction of any black box model by approximating it locally with a simple, interpretable model from Ribeiro and colleagues in 2016. It perturbs the input many times, queries the model, weights the samples by closeness, and fits a sparse linear model to that local dataset. Because it only queries predictions, it stays model agnostic and gives intuitive per feature explanations, though results can wobble depending on the perturbation and neighborhood. Get Lime, and even the most opaque model can answer why it decided this. Curious about the rest of explainable AI? That's the sort of thing we untangle over at standarity.com. See you in the next one.